In particular, it points out that population and consumption, the amounts we all consume, cannot be treated separately. And it's the first report for a long time that has brought population and consumption together. And the Earth's capacity to meet our needs is finite. We can't just go on consuming more and more. And most developed countries and emerging nations, so that's essentially the whole of Asia, is consuming more than is sustainable. But there are 1.3 billion people in the world who are profoundly poor and are not consuming enough. And by the way, you can download a copy of the report from the Royal Society website if you want as well. And so, because I'm from Nottingham, the home of Robin Hood, I have summarized the conclusions of this in what I call the Robin Hood question, which is, can we provide more for the poor without robbing the rich? Because rich people don't want their, and by rich I mean everybody in Hong Kong, not just because you are rich compared to the poor people. Nobody wants to consume less, but we have to provide for the people who are really poor. And so I see this as a big opportunity for green chemistry because we can use our resources more efficiently. So we want to make more product from the same amount of feedstock, of starting material. So what sorts of things can you do? Well, in the context of Brazil, there is, they make bioethanol from sugar, so many of their cars are powered by ethanol or fuel that is rich in ethanol compared to most other countries. And here's me in Copacabana Beach making a video about bioethanol and with my video collaborator Brady. And then there is the Brazilian company Braskem, which is converting sugar to ethanol and then ethanol to ethene and then ethene to polyethylene to make plastic starting from sugar. And what's important that it's a new feedstock. It's using sugar rather than petrochemicals to make it, but it's making an existing product. And what is important when you are thinking of new technologies, it's fine doing wonderful new chemistry, but you still have to sell the product. And for things like polymers, there's already a complete supply chain that goes from the factory all the way to the people that buy plastic bags in shops and so on. So you can use the existing supply chain. And everybody at the conference got this plastic bag, which if you looked at the bottom said that it was green polythene, 100% recyclable. And again, you can pass this round. We also got a green plastic water bottle. It's not because it's colored green, but because it's made from sugar. And you'll see it's no different from any other plastic bottle. So again, do pass it round, but I need it back. You can ask, is it sensible to make chemicals from biomass and biomass plant material like sugar? And the first thing is biomass can be sustainable because the carbon comes from carbon dioxide in the atmosphere, and oil is becoming more expensive, so all the chemicals that we make from oil are going to become more expensive. And bulk chemicals, things like plastics, are made from oil, and they're very cheap at the moment, and they're going to become more expensive, and this is going to have a big effect. Pharmaceutical compounds, medicines and so on, are already very expensive, and the proportion of their price that comes from oil is very small. So even if oil gets much more expensive, you won't notice it much in the price of pharmaceuticals. So one of the targets, I think, for green chemists is bulk chemicals made from biomass. I should say the situation in the short term is changing because of shale gas, which is becoming quite cheap. Is there shale gas in Hong Kong?
I think in every.
I don't know.
It's every continent.
Yes, but and so in America they've got very excited because of cheap shale gas. But it's not going to, I mean, it will last for a few decades, but that will disappear eventually as well. So in the long term, this is what we have to do. This is an example of my own work using a thing called malic acid, which comes from apples. And we've been trying to develop a new route to acrylic acid. Acrylic acid is used for superabsorbent polymers. Superabsorbent polymers are the things that you use in babies' nappies, where they absorb water. Diapers, I don't know, do you call them nappies or diapers in Hong Kong? Diapers. And I've been working with a company called Lucite to try and make a new route to acrylic acid from malic acid, reacting it in high temperature water. So this is malic acid, and if you remove CO2 and water, you then get acrylic acid. And you can do this by heating it up, the malic acid in water, and here you can see as you increase the temperature, the yield of acrylic acid goes up to nearly 50%. And for those of you who are chemists, you can draw curly arrows and you can see it forms the product. And this looks quite promising. There's a lot of engineering still needed to work out how to get the acrylic acid out of the water in a cost-effective way, but it's something which shows promise. And because it comes from apples, I sent my student to the supermarket to buy all sorts of different apple products, apple juice, cider, which is fermented apple juice, vinegar, and so on, to put it through the reactor to see if we could make acrylic acid from apple juice. And it actually worked quite well with apple juice, except that we forgot that apple juice also contains sugar, and so the whole of the apparatus got covered in caramel on the inside and eventually blocked. But the principle was demonstrated. So you can use apple juice straight from the tree, as it were. And I made a video about this. This is me wearing suitable dress for the English summer. And in a field of what in English is called rape, which I can't remember what it's called in America. It's canola. So there's showing here that I'm discussing making chemicals from plant material. So now, again, I want to move forward and talk to you about